Good day everyone, my name is Wendy A. Lusutan from Group 10. My co-reporter is Mr. Darwin Parco and Ms. Vicky Tumagin. Our topic is all about the stomatal control and tomato with ABA deficient roots, response of grafted plants to soil drying. Regardless of root genotype, two tests revealed that stomata loss in transplanted plants in response to soil desiccation. Using the tomato mutants, Sitchens and Flaca, it has been suggested that the ABA produced by roots in dry soil is what causes stomatal closure. Independent of how well watered the leaves are, stomates can close. There is proof that this signal is ABA since stomatal closure is frequently correlated with an increase in ABA in xylem sap before an ABA rise in leaf content is discernible, reviewed by Davis and Zhang 1991. By providing synthetic ABA at levels that are comparable to those found in the transpiration stream, ABA can be made to appear in detached leaves. In modulating stomatal conductance, it is unclear how ABA produced in the xylem differs from that produced in the leaf. The response to soil drying ought to be genotype dependent if ABA generated by roots is necessary for root-to-shoot signaling. Plants with roots lacking in ABA and shoots that resemble wild plants were created to test the theory. For the materials and methods, for the experiments, with mutant sitchens, the researcher used a sandy loam with a maximum water capacity of roughly 0.25 gram per centimeter. Was utilized as the rooting medium, whereas the mutant flaca was roomed in a potting solution based on organic materials in order to conduct plant development tests. Soil with a bulk density of 1.28 kg per centimeter and an organic base growing medium with a bulk density of 0.54 per gram were used. First experiment, which is the reciprocal graft experiments. Using these reciprocal grafts, it was determined how the genotype of the roots, ABA deficient versus wild type, affected the patterns of water use and stomatal conductance in response to drying soil. The experiment was stopped when the plants wilted, at which point the plants were harvested and the total leaf area and soil dry width were calculated. In the Sitchens experiment, plants were allowed to dry the soil at their own rate. No water was added to the pots during the period of soil drying.
Hi, my name is Darren Parco and be assigned to the discussion. And for today's, let's discuss about the stomata closure in drying soil does not require the root source in AVA. With the reciprocal grafts from the wild type of sunflower and the wild wealthy AVA deficient mutant, they reported that the stomata conductance during water stress was determined by the shoot rather than the root. The phenotype or the phenotypic reservations of ABA deficient root in wild type of roots was reported that the grafts of tomato and sunflower, although its leaf ABA was lower when the shoot's genotype was salient rather than the wild type, and thus correlated with the stomata conductance in unstressed plant. It increases much more than a soil drying in the wheat than the set plant. Yet stomata of this plant controlled, so it is possible that the reduce of leaf water status influences stomata conductance either direct or by including ABA accumulations in signals that could be produced by ABA deficient root. Cytokinin concentrations are often lower in xylem sap from drought plant and can be influenced stomatal opening. This could be affected by the ion relations of the upload. In ABA circulations in grafted plants, the ABA could enter the xylem either from the stem below to the point of the collections above the grafted junction by direct phloem xylem transfer, or after recirculations via the roots. In Lufen, it was calculated that only 70% of the ABA in the xylem was being synthesized by the roots. The remaining parts being recirculate from the leaves, and that the salt treated plants, the proportion was even lower, at 55%. Alternatively, the ABA in the xylem from the width to set of plant maybe have not arrived via roots. The ABA may be been made within the stem above that the grafted, or made by the older leaves and transferred into the xylem within the stem intermode tissue.
In conclusion, the overall of this experiment showed that in tomato, as in other species, root signals operate to control stomatal conductase in drying cell. However, this data show that this closure was not related to xylem ABA concentrations, nor to the ability of roots to produce ABA, and indicate that stomates could be responding to ABA that is made in situ rather than transported from the roots via the xylem. The signal from the roots that causes this increase in ABA or otherwise influences stomatal conductase remains unknown, but may be a precursor or related to pH changes that have been observed in xylem sac.